In this video, I'm going to show you energy flow in gas systems. So the example we're going to do is as follows. Explain why the pressure of bike tires decreases in the winter. I want you to notice the hints given in this problem. It says pressure and it says winter. So instantly, with winter, you should be thinking cold. Okay? So the temperature is going to decrease. So the first step whenever doing one of these problems is to sketch what's happening. So in this sketch, we have a tire in the summer and a tire in the winter. And I want you to notice that the number of molecules does not change. There are 10 molecules, 10 dots in each of these tires. But their speed is changing because one is in the summer and one is in the winter. Okay, so we know that one is hot and one is cold. And when these molecules become colder, they slow down, so they have smaller arrows. So step 2 is to determine how variables are changing. So the temperature, as we've talked about, is decreasing. In the summer to the winter, temperature decreases. The volume might be changing a tiny bit, but it's a tire. Its volume is pretty set, so maybe slight change. And when temperature decreases, as we've established, the volume will also decrease. So I'm going to change that to a slight decrease. The pressure is going to decrease. Now, this is the key part. Pressure is the force that molecules hit the walls with. So if molecules are moving more slowly, as they are here, they will hit the wall. The molecules will hit the wall of the tire with less force. So the pressure decreases. In the summer, if the molecules are moving faster, they will hit the wall of the tire with more force, so there will be a higher pressure. And the number of molecules is the last thing you need to look at. And I want you to notice that the number of molecules does not change because the tire is a closed environment. Molecules cannot move in and out of a tire unless there's a hole in the tire, and then you have some other problems. Step 3 is to construct an explanation. Okay, so we're going to be thinking about all of these variables. We need to mention all of them in our explanation. So in the winter, temperature decreases. So this is our established fact. Okay, the problem asked what happens in the winter. So I start off by talking about the winter, and I establish which variable is first affected. In the winter, the temperature decreases. Therefore, the molecules move more slowly. So I go from what is given, the temperature, into how molecules are moving. Molecules will move more slowly. As a result, they will hit the wall of the tire with less force, so pressure will decrease. So now I'm tying in another variable. Since this is a closed system, remember there's no holes, it's a closed system, the number of molecules, here's another variable, will stay the same. The volume may decrease slightly due to the decreased temperature, just like we spoke about, but the volume of a tire is unable to change significantly. And then I refer back to the question and say, therefore, the pressure of a tire decreases in the winter. Step 4 is going to be to draw the LOL diagram. So that first L is our first bar graph with E therm and E phase. And you can really start with any amounts of E therm and E phase. You should have at least one box for each of them. But I think 2 boxes is a good place to start. That middle circle is our system, what we are examining. We are examining the tire. And the outside is our surrounding. So what's surrounding the tire? Well, the temperature is dropping. There's a cold winter environment. So how does energy flow? Well, if it's getting cold, energy will flow out of the tire. So the E therm, because it's heat, we're changing the temperature. E therm, some energy, some thermal energy will leave the tire and go into the environment. And so therefore, when we go from a warm tire to a cold tire, we have decreased our thermal energy, and we haven't changed E phase because it's still gas in there. Tires are filled with gas in the winter and in the summer. Go ahead and try your example. Make sure you hit all 4 of these steps.